A word of caution before we get into section 5.1. Probability is really its own field of mathematics. It's often tied to statistics, but it actually has its own rules and properties and definitions. And so this section 5.1 is actually a particularly long section because I have to introduce all sorts of definitions that you've never heard before. So be prepared. It's not a really difficult section, but it is very, very long. All right, so what are some definitions? Well, the first most basic definition is a probability experiment. A probability experiment is any process that has uncertain results that can be repeated. For example, if I have a die, I can toss that die repeatedly, and every time I pick it up, don't know what it's going to be, so the results are uncertain, and I can do it over and over again. So it can be repeated. Dice, coins, those are some of the most basic probability experiments that we think about, but we'll think about more advanced ones as well. Now, probability is the proportion of times that a particular event occurs in the long run as a probability experiment is repeated over and over. So you want to think about not just one toss of the die, but all future repetitions of that experiment. So in the long run, the proportion of twos that will occur as this die is picked up and tossed repeatedly, that's what a probability is. It's a measurement of the likelihood of that event, right? It's a measurement of how likely 2 is in relation to all these sides. Now, the probability of an outcome is abbreviated P of O, O being the outcome. So for example, well, I'll just leave it at that. And then the capital P stands for probability. It's a function, right? So if you remember in algebra class where you learned F parentheses X stands for F of X, if you've ever learned that in algebra, that's what P is. It's a probability function. Probabilities can be written as decimals, as percents, or as fractions. So for example, if I looked at this die, the probability of a 2, this is a 10-sided die. So the probability of a 2, I could say 2 is 1 out of 10, right? That's a fraction. That's 0.1, that would be a decimal, which is 10% as a percentage. It's just a little example that I threw in there. We use fractions a lot for basic problems like dice and coins and things. But honestly, of these three, the one that we use the most often is decimals. Percents are just decimals written in a way that we can explain them in English. That's all percents are. So percents are kind of decimals on steroids. So decimals are the most mathematically useful. So they're the ones we use the most. A sample space is the list of all possible outcomes. So again, for my example, if I was going to give you an example of a sample space, on this die, the lowest number is a 0. So it would be 0, 1, 2, 3, 4, 6, 7, 8, 9. There's 10 digits there. 1 through 9 plus 0 makes 10. So this is a 10-sided die. And that would be the sample space. It's the list of all the outcomes. All right, so let's look at the American roulette wheel. Dice and coins are great, but let's think about the roulette wheel. So in roulette, if you play this game at a casino, there's this spinning wheel, and there's a marble that's kind of they set the wheel spinning, and then they have this marble kind of bouncing around, and eventually the marble will land in one of these spaces. All right, so in the American roulette wheel, there's 38 spaces. The 0 and the 0, are green spaces. They are actually green in color. So if you're looking at this on the video, you can see there's red spaces and black spaces, and then these two are green. The rest of the numbers are 1 through 36, and they're evenly split between red and black. What does it mean when a casino says that the roulette wheel is fair? Okay, so let's think about this. A fair game would mean that each of the outcomes, well, fair experiment, would mean that each of these numbers is equally likely. No one of these slots is more likely than the rest. So each number, including the 0 and the 0, those are numbers, is equally likely. All right, now the sample space. Well, I'm not going to list them all up because it's huge, but we're going to make a list. So we start with 0 and 0. Oops, there's no comma there. I don't know why I was doing that. So 0 and 0, and then it goes 1, 2, 3, 4, and it just keeps continuing up until 36. That's the sample space. All right, now P of 4. 4 is right here. If you see it right there, that's the 4 position. So what is P of 4 in words? So P of 4 means the probability, because capital P stands for probability, the probability of, the parentheses usually means of, the marble landing on 4. It probably has some official name, but it always looks like a white marble to me. Right, so landing on the 4 slot. Now, what is the P of 4? So words is right here. Sometimes we'll just say English, right? So English words. So sometimes I'll say, what is it in English? What is it in words, right? Same thing. And then what's its value? Okay, so the value, that means find the number. So P of 4 equals, well, there's one 4 slot out of 38 total, right? Because there's 36 numbers plus 2 more. So 38. All right, well, let's see, 1 out of 38. You can tell I was replacing this video. So 1 out of 38 is 0.026. Okay. 0. I'm going to put an approximation because I'm rounding, of course. So it's 0.0263, which is 2.63%, because we have to move the decimal 2 spots over to get a percentage. That's the hundredths place right there. So you move the decimal to the hundredths place because it's percent. Now you'll notice that 4 is actually something called a simple event. I'll just make a little note right here. So note 4, landing on 4, is a simple event. All right, what does that mean? Well, it's defined at the top of the next page. A simple event is any event that has only one outcome. Right here, right? Only one outcome. Lovely. Okay. So an event in general is any collection of the possible outcomes of the experiment. So you could define them all sorts of different ways, and we will. So there are lots of different events, but a simple event is one that can occur only one way. And we generally use capital letters like E for event, F for event, that kind of thing. So it doesn't have to just be E. So F, G, H. We'll use A, B, C as well, right? Those kind of letters. All right, suppose you're going to spin on an American roulette wheel once. The following shows the betting board at a casino. So they have that wheel right next to this board, and on this board you place your chips. And we have a chip right here being bet on the second column, which is a 2 to 1. You can see there's a 2 to 1 space beneath it. So it's called a column bet, as it means you're betting on all 12 of those numbers. Okay, so we're going to define the event E, which is the second column. Well, the second column means you're voting on these numbers, right? You're betting on these numbers to win. Voting, betting. Not the 0 and the 0, 0. They don't count as part of the column. So you're betting on 2, 5, 8, and so on. So event E is 2, 5, 8, 11, 14, 17, 20, 23, 26, 29, 32, oh, I can just fit it in there, and 35. There, that's the second column. And is this a simple event? No, right? Not even close. There are 12 outcomes in event E, not just one. All right, now what is the P of E in words? All right, so words, aka English, sometimes I'll say English, same thing, right? So P of E, probability. I should say the probability, but That's the probability that the marble lands on a number in the second column. Right? All right, now the value of it in word or in numbers. So P of E is, well, there's 12 outcomes in that. So there's 12 out of 38 total, right? I know it seems like there's 36, but you can't forget about the 0 and the 0, 0 at the top. So there's 12 out of 38, which is 0.316 if I'm rounding to 3 decimal places. And I'll use the approximation symbol because we're rounding. And if I wanted a percentage, you move it 2 spots over and it becomes 31.6%. All of those values are correct. It's just a question of which one do you want to use. Now I used to include this in Appendix A, but I don't believe it's there anymore. Let me check. Yes, I cut it from the most recent version of the exam appendix. That's because you don't really need it. If you're given a roulette problem, you're given enough to figure it out. So I'll just cross that off. It is actually available in a worksheet at this current moment. Yes, I tucked it at the back here of Chapter 5 Review Worksheet number 4. So that's where it is, the basic roulette information as well as all of these bets. But what happens with the worksheets, honestly, is that I give you enough information in the instructions that you'll be able to figure it out without really knowing roulette per se. So if you want to know for more info on roulette, see Chapter 5 Review Worksheet number 4. I go through all the basic bets in there. But again, all the worksheets, I was able to cut it out of the exam notes packet because all the worksheets and such that includes it, the information is included that in the instructions, so that enough so that you can figure out what you're doing.